Okay, so the first thing you do on a compound inequality is you want to isolate the variable. So what do? You subtract the 6 first. So I have some folks from the discussion, I can tell some folks, they divide by 5 first and stuff, and that's not a good idea. You know, you always isolate the variable term, meaning you want the 5x by itself. So you say, how, if I want it by itself, what do I have to get rid of? This 6. So I'm going to show you some of the basic math in here so that maybe if you have a gap, we can fix it. So then you have a 5x is less than 1 minus 6 is negative 5. Yes? Then you isolate the x. So first you isolate the variable term, then you isolate the actual variable. Right now, what's being done to it? It's being multiplied. You have to do the opposite of multiplication, so you divide. And I know for some of you, this will be a little bit boring. I can't help it. I do want to get to the folks that have basic math issues, you know. So then you have an x is less than. Negative 5 divided by 5 is negative 1. Yes? And there were a few people when we were doing the there was one of the on the discussion board, and it was m is, and they had a negative 2 over negative 2, and this is how they ended up working with it. Like, they didn't turn this into a 1, you know. That's kind of a problem. You have to understand that negative 2 divided by negative 2 is a 1. So anyway, negative 5 divided by 5 is a negative 1. So you have x is less than negative 1. So here on this graph, let's just put, I don't know yet how this one's going to turn out. So I got to isolate that one too, but I like to graph one at a time. So let's just put my 0 here. You should always put a 0, and on the computer it'll give you a graph, so it's not an issue. If I ask you to do one for me, I want to see the 0. I want to see the values where it ends. So now it says internet connection unstable. Am I freezing again? No.
Yes.
Okay. Yell at me if I'm starting to freeze again, then I can do away with my video. X is less than negative 1. So here's a negative 1. Less than means it has to be somewhere over here. Yes? So James, you're pointing. Very good. So you're saying less than over there. So this way. And do we agree that anything I shade has to cause a true statement? So if this is a negative, negative 1, 2, 3, 4, let's say this is a negative 4. Is a negative 4 less than negative 1? Totally true. It has to be true. So you know you shade it in the right place. Now, let me erase here. Okay, so a couple of rules. If you've not seen this, some people seen the full dot and the open circle and stuff. We don't do that in this book. In this book, we use the parentheses and brackets. So you use parentheses when you have a less than or greater than. You use brackets when you have a less than or equal or a greater than or equal. Okay, so if it includes the line, it's the bracket. And if it doesn't include the line, then it is a parentheses. Parentheses means end value not included. So you're going to say, oh, x is less than negative 1. You see, you have to not include the negative 1. And this here means it's not included. So negative 1 is less than negative 1. That's not true. So you have to say, oh, this negative 1 itself will not cause a true statement. Okay, so we graphed this first one. Now we have to do the next one. So I like this specific example. A lot of these are going to be simpler than this. So I'll show you a couple of those where the keyword, and then we have to deal with the ands and the ors. So let's first isolate the variable. What do you do first? You need to isolate the variable term, meaning the negative 4x needs to be by itself. So what do you have to do? You have to get rid of the 3, so you subtract 3. Yes? So that's important. I know it seems so basic, but it's so important. And then you have a negative 4x is greater than. Then you say, oh, I borrow 17, I borrow 3, I owe 20. And then you have to isolate the variable. So it's a negative 4 times x, so what do? You have to divide, yes? And you're going to divide by negative 4. Now, you folks, and I'm going to show you this because I saw some weird stuff, and I know I think you've already watched some of the chapter 3 or module 3 and 4 videos where I'm telling you it's okay to be wrong. It really is. It's not okay to quit. But I'm not saying it's you know, I want you to not think in terms of smart and not smart, because that's not how this works. It's like being able to learn, being, you know, teachable. But I have a bunch of people who do this. You know, you can't do that. That's not how this works. You want to isolate that X, you have to do the opposite of what's being done to it. So please don't, if you have basic issues, we need to meet so I can fix that for you. Okay, negative 4x divided by what is 1x? You want to know what 1x is worth. Sorry, now it's the dogs. Negative 4. Do you all believe it? Negative 4 divided by negative 4 is 1. So then you have 1x. That was the goal. And then here's the deal. If this is a rule, if you divide by a negative, and this isn't going to be pretty, you need to flip the symbol. I'm going to call it a symbol, not the sign, because some of you will think in terms of positive, negative. You're going to flip that inequality symbol. So when it, and the key is I'm dividing by a negative, meaning the negative is in the bottom. You see this? So if you see a negative in the bottom, you better flip that symbol. This thing's going to turn into a less than instead of a greater than. Yeah? So you need to be careful here. If this is wrong, your graph is wrong, everything's wrong, you see? So these little things can really make and break your grade here. Negative 20 divided by negative 4 is a positive 5. Yes? James, did you have a question? Or you just, we're good?
I was my 5.
Oh, there you go. You got to the answer. Patience. No, sorry. Okay, so yes, very good. You're participating. And everybody's paying attention almost. So that's good. Okay, so then you graph this one. And I want to clarify here because students then they want to flip the symbol all the time. You know, they see this like here, you can see my pen, right? This negative 5, they see this negative 5, and they say, oh, I'm going to flip the symbol. I didn't flip the symbol because I didn't divide by negative. You see how I divided by regular 5, so that doesn't apply there. Do we understand the difference? Like, you don't want to flip symbols when you're not supposed to. Only if you're dividing by negative or multiplying by negative. Okay, so now you have x is less than 5. Okay, 0. 1, 2, 3, 4, 5. Less than. And then I'm going to use that same similar scenario and do a bunch of stuff to it. So if it's less than, some people graph like this. I'm like, that's not going to fly. You need your graph to show what's going on. And you only know that if you graph it all the way, whoops, and this isn't going to be pretty. But do you see how this here, this line here goes with that? This piece here goes with this one. Are we clear? How done? Super boring or just informative at the moment? Hopefully informative. Okay. So then you're still not done, and you have to, people struggle with this stuff a lot. So this is where the key word is the following. This and here is your key word. Yes? So your key word, and I don't fiddle with that really until after I graph them. Keyword is and, or you might have an or. Okay? So if you have an and, you need to say and is an intersection, and I did this in great length too in the video, so if you need to watch the video, I shared another one today over chapter 9. This will be helpful. But and means intersection, and intersection means double shading. And if you just memorize those 3 things real quick, and I usually use other tools, but I'm a little worried about timeline, so I'm going to go ahead and not go crazy on this. But and means intersection. A-I-D. We could do it that way. Give me some aid. Band-aid. Double shading. And what that means is, this is a compound inequality. Look at this. What would make a true statement for that whole thing? Or let's look at them from this perspective here. Let's say, what if I say, hey, is the solution set, or, you know, is a negative 10, for example, I'm just making up an example, included in the solution set? Solution set is everything that makes it true. You know, let's just look at that. Don't write this down. I'm just kind of brainstorming. So if I have a negative 10 over here, do you agree that at the negative 10 that you see double shading? And if you see double shading, it means it should cause a true statement for both. So do you agree that negative 10 is less than negative 1? If I have negative 10 bucks in the checking account, I have less money than if I have negative 1. And do you agree that negative 10 is also less than 5? That one's easier to understand, yes? So
yes.
If it's and, it has to be true for both statements. If you use the word and, yes? So that's why I say, in the book, a lot of times it'll say, oh yeah, here, solve the compound inequality, graph the solution set, and give the answer in interval notation. A lot of times in the homework, it'll say, solve the compound inequality, write it in interval notation, and graph. You don't ever want to do interval notation first. You want to graph first, because the graph tells you exactly what interval notation is supposed to look like. So I'm going to erase. I can undo, but I'm going to clean this up for a minute. So interval notation. Whoops, I'm on eraser. I tell my students, if they would just do it right below the graph, they wouldn't have the problems they do. But if they don't listen, you know, they put it over here somewhere. Just go right below the graph and say, what do I see? Where is my double shading? This is the graph that MyMathLab wants. This here, where you see double shading. Do you understand that you cannot include this here? This you're going to have to kind of do away with it for the final answer graph. If it says and. So then you're going to say, oh, okay, what is double shading? Oh, it's right here. And it goes, where does it go? Where does it start? And we grab it and say, where does it start? Oh, it starts with the parentheses, and it starts at the -1. And this right here also says -1 not included in the final, the actual -1 is not included. And then you put a comma, and then you say, where does it go? And what's over here? All the way to -infinity, like forever and ever. And this is now your final answer in interval notation. And it's super easy if you just use a graph. So then we're going to do the scenario with the other word. So then I usually end up running out of room in Zoom because I'm trying to see you guys so I can gauge and see that I'm doing my job here. But now that I've made you smaller, I see 4 people instead of everybody. Let's use, it gets a little messy in here, I can't help it. Let's do the same thing in green, yes? So I'm going to do just the sketch, and this is going to be my OR, okay? So I'm going to make my OR in green. If this problem had an OR, not an AND, my graph, my original graph is still the same. I have a 0, I have a -1, x is less than negative. You see, these two things don't change. X is less than -1, and x is less than 5. So this was my original graph. And then I look at OR. And then I want you to think of OR as union. Union. OR means union. Union is, I like to memorize it like OU, like I owe you money, you like that. So OU goes together, AID goes together. Okay, OR and union. Union is just like if they're married. You know, this is all the stuff she brings here. This is all the stuff he brings here. He brings more than her stuff. And then he, you know, they have the same thing, but he also has a, I don't know, what does he have? A chainsaw that she doesn't have. But as a union, you don't double, if you have a double toasters, you just sell the toaster. But what do they have together? So OR means union, and that's any shading. Okay, any shading. So you say, okay, this case, what do I see? Where do I see any shading? Oh, any shading goes here. My internet connection's unstable again. I'm frozen. Hold on. Chat, I'm gonna read your chat. Oh yeah, it starts at 7. It's okay, you just have to catch up or watch the video later after I put it on YouTube. I just really hope people are using those because it's time consuming for me to do this stuff, and it's really time consuming for me to upload them to YouTube. It takes like 3 hours on my computer. I don't know why. So then you say, what do you see for interval notation? You say, oh, it starts at 5. Where does it go? To negative infinity. And that's it. Are we good? And then I'll make up a bunch more scenarios because this is where people get confused. So, and they don't always look like this. So can I clear this screen, or I need to take roll too? But I saw, oh wait, did somebody leave? We have 10 participants. Wasn't there Kayla here? Wasn't Kayla here? Kayla Reed? Okay. Well, you might just have to email me again, or I can take a screenshot again. I hate to aggravate you like that, but I can't remember from now until 5 minutes later. I mean, I know a few of you that have been here before a few times, sorry. Okay, so I'm gonna clear the screen and then we're gonna do something else. Same thing, but something just, all the other scenarios that could happen. Hang on, I'm gonna get rid of this. So this is gonna be the same, and after this, we're gonna do the 9.4. 9.3 is absolute value, so I haven't gotten any questions on that yet. So I'll stick with this for now. Okay. What if I said the same instructions, you know, but x is less than 2 and x is greater than 3, greater than or equal. Okay, so I'm just making this up now, and we're not actually going to solve and spend all that time solving. I want to worry about the graphing and the interval notation. So, and maybe I should have made it -2. Let's do a -2. So we have a 0, we have a -2, less than, so we do the parentheses and we go to negative infinity. And I hope that's okay. If you have trouble, please communicate. I see some nods, so then I'm like, okay, I can move on. But if you're not sure, okay. And then x is greater than or equal to 3. 1, 2, 3, and that part doesn't bother me. Like if you offer a deal there, I don't care. I care about you understanding how to do these, how to put them together. How to, so this time, this is the scenario, and it says and, so you graphed it, and now you have to do interval notation. And means intersection. Intersection means double shading, or really, where do they meet? Think about it, intersection on a road. You know, you drive here, I drive here, together we meet right here, right? Makes perfect sense. So intersection, where do they meet? Double shading. Do they meet?
They do not.
They do not meet. So he brings a bunch of junk, she brings a bunch of junk, they have nothing in common. They're gonna make it work. So then you say, well, and means intersection. They meet nowhere, so your solution set is no solution. Or it'll say an empty set, which looks like this. This is a solution set notation. But don't put that circle inside of a parenthesis or inside a bracket. That's not gonna work. Does that make sense? Intersection. So then what if it said or? You know, so we're going to use the same exact scenario. What if it said or? Same thing. So the first part, you don't do anything different. But or is you know, and I'm going to go ahead and my sketches are hideous. I'm obviously not an artist. 0. It's not my thing. Okay, and here's my 3. So you say, well, or means union, and union is any shading, you see? So I said, well, drop below the graph and write and say, what do you see? What do you see shaded? Oh, I see a -2, and it goes to negative infinity. That's that arrow. I see a 3. See, you can't just say negative infinity to positive infinity in this case. You also can't say, some people say -2 to 3. That is exactly what it's not, because that's exactly all the values that don't cause a true statement. So be careful. And then you see a 3 in infinity. And so here's the thing. If there's a gap, then you have to put in a union. So I'm going to say if, then you need to put in a union. This is a union symbol. It looks like a U, so that part's really easy. Now, sometimes in the book, you'll see an intersection symbol. This is an intersection symbol. This means and. Yes? So I don't memorize the and one really. I just memorize the U's for union. So that's easy. And then I say, oh, the other one must be a bridge. Okay. Now, what if, hold on, we got 2 more scenarios. What if, you know? So now what if it says, I'm going to clear all drawings. Are we ready? I can get rid of it. Yes? Okay. Okay, I'm just trying to listen in case it's me. What if I say x is less than 1 and x is greater than or equal to a -4, let's say. You know, I'm just making this stuff up as I go along. That keeps life interesting. -4, -3, 2, 1, 0, and then here's my 1. So x is less than 1. Here's that one. Yes? And I'm trying to go slow, but I'm trying not to go too slow because some of you are not taking notes and I don't want to bore you to tears. And I know we all have a life and kids are going to start popping in at any moment. Okay, greater than or equal to -4. Greater than or equal means bracket. Then it goes in this direction. Yes? So you always graph, and the internet connection is unstable. You always graph. And then you say, what's the keyword? And means intersection. Intersection means double shading. Where do you see double shading? I see double shading between -4 and 1. So your final answer on a graph in MyMathLab is not going to look like the original. It's going to just look like this. And this is what MyMathLab is going to have shaded. Do you understand? Like you're not going to see that stuff over here and that stuff over there in MyMathLab. And then the last one, I mean, I know there's others, so we'll see. And if it said or in the same case, you would say or means any shading. And now look at your graph. Any shading, where do you see any shading? You see, all the way from -infinity all the way to infinity. How are we doing? Is it crystal clear? And if not, like I said, there's a video already that I put in announcements. I'm trying to figure out, do I put the videos in the modules? Do I put them in announcements? If I put them in announcements, do people lose them? I mean, I'm like, you can always go back and look at all the announcements, right? And I try to put in the title what you're going to see roughly, so it should be okay. How are we doing? Then let me do one more graph and make sure I've got it covered. Just one more, like just the visual. Let me see, what else could we have? We did the no solution. We did the one where it was a union and it went one way. So if we had said x is greater than 2 or x is greater than or equal to 3, we already covered this, right? 2, 3, and your zeros over here. That was not a very good job on my part, but it doesn't matter. What would the answer be here if I said or here? You would say any shading, so your final answer is from 2 to infinity. Did we see it? Any shading. And if this one said and, it would be from 3 to infinity, because that's only the double shading. And do you see how this is the double shading? That doesn't include the original number line. Are we feeling pretty good?
Yes.
Yeah, very good. So now I'm going to answer Ashley's questions. I'm glad she sent them because 9-4, and I think if we do one in detail, then it'll answer the other two and we'll do them faster. I'm not going to do 9-3 if people don't have questions, and it's also covered already in the other videos that I'll share, or that I've already done it or whatever. Yes? So, can I clear it? Are we ready? Okay, you can always later look at that video and fast forward and whatever. It's really hard for me to do this with the, I love the feedback and the visual and the, you know, it's really hard to do this stuff. Okay, 9-4 homework questions. Good, and this also addresses some of the basic math issues if people have them, because we're gonna isolate some more variables. Okay, so it says graph the following inequality. Okay, so now I'm gonna say something that I'm gonna contradict myself. If you're graphing an inequality, and this is, do you see how this is in 2 variables, meaning x and y? This is gonna be a line in the coordinate plane. So I want you to first find the points on the line. You're going to graph it, almost graph it as if you're ignoring the inequality part. Find points on line, meaning not online, on the line. And you kind of act like it's a regular line. What I don't want you to do, people do this. They do an XY chart, and then they use this original, and that is very confusing because so many values will be true when it's an inequality that this is not going to work with the original, but this will work with the regular line. But I don't want you to forget later that it is an inequality. So first, you're going to treat it like it's a regular line. Yes? Just to find your points. Now, some of you like the y equals mx plus b thing. Some of you like the XY chart. This is good review over chapter 3. If you have trouble graphing, maybe now graphing will become more clear. So if you are one of those y equals mx plus b people, you know, at some point you have to learn that there's different methods, and you have to accept that you'll just figure out which one you like better. If you want to isolate the y, you would subtract 4x, and you would have a 2y is negative 4x plus 8, right? I mean, that's something you need to know anyway for chapter 3. Then you divide by 2, negative 4 halves, and plus 4. This is the way the line would look if you did y equals mx plus b. I tell you usually, if it starts out standard, just do the XY chart. It's easier, okay? So this XY chart, you did this in online discussion number 2 or whatever, 1, I can't remember, number 2, I think, where I said, hey, find the intercepts. And you said, oh, I put a 0 in for x. Look at your original. This would cause, and we're treating it like a line still, because we're finding the points on the line. So if you let x be 0, doesn't that turn into a 0? So then you have 2y is 8, and then y is 4. 8 divided by 2 is 4. When x is 0, y is 4. Yes? So in the classroom, I just start with this here and I just cover this piece up with my finger if I use a 0 for x, because 4 times 0, anything times 0 is 0, you know. So it just disappears. Poof, it's gone. Okay, so if y is 0, then you can do it the long way and say, oh, 4x plus 2 times 0 is 8. Or you could have just covered up this y and made it disappear. So you get 4x is 8 and x is 2. And then I always do a checkpoint in case I'm graphing wrong. If I made a sign mistake right now, I can catch it. So what if I say x is 1? I think that might work. If x is 1, you know, I'm trying to avoid a fraction here. If x is 1, 4 times 1 plus 2y is 8. Now I have to expect you guys to be able to do these basics. So if you're struggling here, what are you supposed to do? Alarm, alarm, please help me. You know, you got to fix that issue. You're not going to want to do this after the test. So seriously, a lot of the issues are that students ignore the problems, and I want to help them. But -4, I can't read your mind, you know. 8 minus 4 is 4. 4 divided by 2 is 2. So according to, this should be a straight line. If it's not, I made a mistake.
It is.
Okay, very good. So 0, 4. This is me graphing or finding the spots on the line by just doing XY chart. 0, 4. 2, 0. Some of you have these backwards, so you need to fix that. 1, 2. Do you see how this would cause a straight line if you connected the dots? And it has to be straight if you have x to the first, y to the first. This is not a curve. Now, what if you said, hey, I want to do it y equals mx plus b? You know, the green way. Y is mx plus b. See this way. If you said, I want to graph it this way, this is my y-intercept. Again, review over chapter 3. This is my slope. So y-intercept 0, 4, you see it? Slope is -2. M is -2. -2 is -2 over 1. Rise, run. So you either drop down 2 and run over, or you go up 2 and to the left. No matter what, you're going to have a negative slope. How are we doing with the basics? This is basic graphing again. And like I said, I review a lot while I work because I need for you guys, this is critical. Like if you can't graph a line, you're toast. I mean, I tell them that in the classroom all the time, and then it comes across a little better than on Zoom. But, you know, you don't want to mess with this. You need to know how to do this really well. Okay, so then here's the deal. We found the points on the line. Why am I not connecting the dots? Because this is an inequality. And this is where it's critical right now that you don't just connect the dots. You need to say, oh, if it's greater than or less than, it's a dotted line. If it's greater than or equal, less than or equal, it's a solid line. Yes? So that's the rule there. So since this is a greater than or equal, greater than or less than, then it's a, or they call it a dashed line, and the, you know, and that's something, it's a tool you choose out of the MyMathLab toolbox when you're graphing these. So this is not going to be straight because I'm sketching, but this is what my line would not look like. You will use a ruler or something. You have that tool. Somebody last semester was like, why don't you use that drawing tool? I'm like, yeah, but I still have to be at the exact perfect spot or it won't bring it across right. And I don't feel like fiddling with it. Okay, so then I'm still not done. I'm almost done. So now you have to shade. You have to shade. Shade because it's an inequality. See, either all of your true points are over here or all of your true points are over here. So Ashley, is this helping at all, or is this, you already knew how to do this stuff and you're just, like, I'm asking because you asked those questions.
I know how to graph it, and I got the graphing correct.
Yep.
It's the shading part that
so
I don't know if it's not.
So now I should be able to clarify that part. Like, at least I'll be useful now. You just have to hang in there when I start from scratch because I want to make sure we really get the problem. Okay, so the shading. you have to choose a test point. And I'm going to call that a test point, not a checkpoint. This one here for the graphing, like to find where the line was, I call that a checkpoint, making sure my line is straight and it's correct. I'm checking my line. But a test point, it sees which side of the line causes true statements. So choose a test point. Now, you're always going to try. So always. There's only one time when you can't do that. Always use 0, 0, x, y, right? Always use 0, 0, because it's the easiest thing you can mathematically do. You can choose any point. You can say, hey, what if I choose 6, 8? You know, this point here is, if it's true, then I shade over here. If it's false, I don't shade over here. But why would you choose a thing that when you plug it into the original, you have trouble? You know, you want to do the easiest thing. Always use 0, 0, unless your line goes through the origin, because then it's pointless. See, if my line went through here, wouldn't 0, 0 definitely have to cause a true statement no matter what? It wouldn't tell you what side to shade on. It would just tell you my line goes through 0, 0. Well, that doesn't help. But you always use 0, 0 unless you can't, and that's the only time. So I call this thing TP, you know, I try to have a little fun, but TP, toilet paper, you know, that thing kind of looks like it if you connect it, whatever. Okay, so let's use TP. That's a good idea, except during COVID when there isn't any. Greater than 8, okay. X is 0 and Y is 0. And you're asking, this is question marks. I struggle with my question marks because they're German ones, just like my F's, and people don't like them. Okay, so 4 times 0 plus 2 times 0 is greater than 8, question mark. Is 0, 4 times 0 is 0 plus 2 times 0 is 0, is 0 greater than 8, question mark. You're asking, is it true? T or F? True or false? 0 greater than 8, false? If it's false, then shade on other side. Other side. So we're going to do the other 2 scenarios too, and I'll graph them faster because the graphing, finding the line isn't the point that you're trying to make. You're trying to figure out where to shade. So look, this point 0, 0 in this specific case caused a false statement. So I can't shade over here because you can try any point. You can say -4, 1. Will it cause a true statement? Well, if you plug it in, it'll cause a false statement. You're going to then have to shade on the true side. And this is where MyMathLab gives you a little bucket, and you put that bucket there and click on it. The shading bucket. Did that help, Ashley, so far?
Yeah, and I shaded up 0, 0 point, and it kept telling me it was wrong. And you know how it gives you the comparison of the correct answer to your answer?
Yep, yep. So
And they were both exactly the same. But it keeps telling me it's wrong.
Okay, so I will look at them again and I will show you why, because there's some minor thing, like sometimes a student accidentally, it seems silly, but sometimes a student accidentally like has this line graphed. Oh, you know, like everything's right, but there's some weird thing that caused a line right there or something, and that's why. Let me analyze that.
Okay.
Is it from the ones you emailed me, right? Those ones.
Yeah,
Okay.
but I didn't answer. The ones that sent you were blank, so.
Okay, so tell me, do me a favor and go into your grade book. You know, you have your MyMathLab grade book, and you go in there and click review, and you look at those, and you tell me the numbers so that I'm not looking through there searching, but you can say, hey, on number 8, on number 9, on homework, such and such. I will look at them, and I'll figure it out.
Okay.
And I can fix your grade.
Okay.
If you're right and the computer was, but if that's the case, I need to investigate that anyway, because that shouldn't happen.
I've
So-
answered all 3 of those questions I sent you over 20 times, not even exaggerating.
Yeah,
And
that's
it
really
keeps telling
frustrating.
me.
Okay, so next time when you do it
I had a
twice,
problem,
go ahead and
mine was
send me.
the opposite.
Go ahead and send me an email when you do it twice, and that way I can investigate.
Okay.
Yeah, show me what you
Okay.
answered, or just send me, because I'm here to help you guys. I don't care if it's a weekend. I do a lot of stuff, so sometimes I'm not in front of the computer for 5 hours or whatever, but I do want to help you, and I don't want you all frustrated. You have, move on to something else, you know, if you can, and let that go so that we can fix it. So we did that one, we'll do this one.
Hey,
Is it-
Ashley, was that the very last problem?
It was number 3, number 4, number 6.
Oh, all right.
In 9-4? Okay, I will investigate. I would do it now, but then my computer is really gonna have a fit, so. Kelly, did you have something? Because you said, I think you were
Oh,
saying
no,
something.
I was just gonna say, I thought one night that I had the question right, but I had mine on the opposite
Yeah,
of the answer that I emailed you, because I thought it was right and it told me it was wrong, but I went back in and I seen where I had messed up. I did it on the opposite side of the graph thing.
and it can get really frustrating. You know, I completely understand, but we have to figure it out. Okay, so here, graph inequality. So again, we're gonna act like it's a line. And then my graph is gone, but that's okay. So y is, in this case, it's quick to do negative, oh, I'm gonna act like it's a line. That's what I said. Negative 3x plus 2. So this is my y-intercept, and this is my slope. Or I can do my xy chart. XY chart always works when x is 0, y is 2. When y is 0, though, then you're gonna get x is 2/3. That's a problem. Oh, yep. They're my foster dogs. They're yet more than my own, but they're sweet. What if y is -1? Let's do that because I wanted something that doesn't cause a fraction. 3x minus 1 is 2 plus 1 plus 1. 3x is 1. So let's look at this one. So yes, I have you guys' faces on the right, so I can't see that graph, so I'm going to sketch it, okay? It's not going to be pretty, just like always. 0, 2. 1, -1. And do you see how this one here, I would use that one as a checkpoint because it gave me a fraction. I don't like it. But when x is 2/3, y is 0, that looks about right, you know. And on your graph, it'll look better. Now this is less than, so it's what dotted, right? Or dashed line. It's not solid.
Yeah.
So, you know, again, this isn't pretty, but this is not the big thing that we need to learn right now. And now we're gonna see where's the shading. Test point. 0, 0, only, we don't use it if the line went through it, but it doesn't go through it. So we can use it, which is nice. 3 times 0 plus 0 is less than 2. Because this is when you don't use this line, you use the original. Yes, for the test point, you use the original. 3 times 0 is 0, 0 plus 0 is 0, 0 is less than 2. True?
True.
If 0 is less than 2 is true, we shade on the true side. Yes? You always shade on the true side. So in this case, you would do that. And that's what you did, Ashley. So you said 3, 4, and 6. Okay, I'll have to look at that later. I'm very interested now. Because when my MATLAB messes up, I want to know about it. Okay.
Yeah, it was very frustrating.
Yeah. But yeah, again, please don't get that frustrated. Make sure you call me or email or something, walk away from it, because we can fix it and you can spend your time better somewhere else. There's something going on there that I need to investigate instead of you wasting your time and getting frustrated.